Welcome to MOOC Cartographic Techniques practical session. In this session, we are going to discuss about spatial data creation and mapping. So, spatial data creation and mapping, spatial data we are getting from topo sheets, one of the major sources. Survey of India produced 1:50,000 scale topo sheet. That topo sheet we already scanned. The scanned topo sheet input for our spatial data creations. So, that spatial data we created in the three way, one is a point, another is a line, another one is a polygon. So, we created that spatial data. So, topo sheet is a major sources for creation of spatial data. Here why we want to digitize the topo sheets? Because there is a topo sheet nowadays, there is a remote sensing satellite images is there, but its Survey of India produced the topo sheet. The topo sheet it is produced on 1970, 1968, 1973 that period. So, but in the satellite image available after 1980 like that, when compared with that historical data and the present data, we need some authentical historical sources. So, that authentical sources is the topo sheet. So, what are the temporal changes? If you want to find out the temporal changes, you have to know that what was in the past. So, from that what we can find out that what is a trend. That is why we have to digitize the topo sheet is a very important. Then analysis, what was in the past, what is the present, we can possible to analysis. So, find out that what is the temporal changes. For example, you see some of that in Chennai or wherever in India, urbanization is happen, most of that water body is that converted into the built up land or other land uses. How we understood that, how we analysis based on that topo sheet and here satellite images, you can compare this analysis. It is possible through the digitization of topo sheet. Then accessibility and application, this everything is possible to do that digitize our topo sheets. So, when we do that digitization, what are the pre-processing and what are the preparation before we have to take means, first we have to select the topo sheet, then second map condition and assessment, then third coordinate system and projection identification. First selection of topo sheet, that topo sheet it is maybe is a medium scale or large scale is a very essential. 1:50,000 and 1:25,000 topo sheet, there is we have that much of detailed thing is there, information is there, we can get it, and first we first we scanned, then that topo sheet converted into the digital. So, that topo sheet we inputted to the GIS software. So, topo sheet first we want to select which area, what we are going to digitize, these all are the first pre steps, first we preparation that topo sheet. Then second is the map condition and assessment. Our topo sheet either that is a clean or flat, if you are the folded the topo sheet, that line also marked in the topo sheet. So, we have to carefully check that the topo sheet is a clean, or sometime we scanned means that time also some error is occur, some not clearing the visualization of the topo sheet. So, we have to cross check that. Then third one is a coordinate system projections. So, that four corner the topo sheet have the latitude and longitude value, then which projection the topo sheet is created, either Everest 1830 or WGS 1984, which projection system and coordinate system they followed. These all are the information. When we do the digitization, we have to pre-check these all are the things. Then digitization method, we have the three method usually cartographer and geographer there follow. One is a manual digitizing, then heads of digitizing, second one is automatic digitizing. So, manual digitizations in the topo sheet is there, we have to tracing sheet and digitize the manually. The now GIS techniques we are using, once scanned topo sheet that is input to that our GIS software, then we georeferenced based on that some GIS tool available in GIS software. Then automatic digitization, some of the upcoming software is there, we create some codes and some automatic default tools is there, automatically they are digitized. So, these all are the digitization method presently nowadays. So, what are the steps? We already saw that free steps. So, what are the steps we follow to the digitization? First we have to scanning the topo sheet. That topo sheet is that maybe the resolution we have to give the high, then only we can visual clearly. So, advisable 300 to 600 and 700 dpi resolution, that is very important to do the scanning. Then scanned images may be in the TIFF or JPEG format, it is necessary. Therefore, we can scan it properly and calibrate it. First is the scanning. Second one is the georeferencing. Scanned images we give input to the GIS software, from that we do the georeference. So, properly we want to georeference and we fix that coordinate system, then only it is give more accuracy. So, first step is the scanning, second step is the georeferencing. Then third step is the digitization. Digitization and layer creation and attribute data entry. Here some software first is the layer creation is there, then after digitization. Some software first we can follow the digitization, then we do the layer creations. So, here layer creation we can apply first. Layer creation means either your data is a point in the topo sheet, there is a point data, what are the data is there, settlement and other trees, temple, benchmark, post office, these all are the things come under that point data. Then line data, river and road network, this everything come under the line data. Then polygon, any forest area and water bodies, these all are the come under that polygon. So, first we want to do the layer creation, then we digitize in the systems. The third one is the attribute data entry. Attribute data means data about the data. So, what is the settlement, what is the road name and what is that name of that forest, what is the name of that water body, this all are the information we feed in that software, that is called that attribute data. Quality control measure, when we do the digitize, we have to note that any snapping, topology rule, error checking, this everything we have to check it. So, here quality control measure, when we do that georeference, digitization workflow. So, first is the scanning, quality control measure. When we do the digitization, that time digitization we simply we can say that tracing from the georeference topo sheet we digitize. Okay. So, quality control measure, snapping, the topology rules and error checking, these three things we have to carry out to do the quality control measure in that process of digitization. Here ensure vertical align and properly between the future, creating clean connections. So, this everything we have to check it in the tool in that ArcGIS and QGIS, there is a snapping tool is there. Then topology rules, when we digitize there is there is a one road is there, another road exactly we have to fix it. So, you look at this picture, exactly connected that road, one road with the other road or one water body with the other water body. So, this is the corrected one. Here see this picture is the undershoot. Undershoot means you want to this line connected exactly with the this line, but it is not connected, but when we do the digitization we can't able to identify that things. So, we have to carefully do that, that is why we are using the snapping. So, snapping tolerance how much, 1 meter, 2 meter, like that we can give it. So, when we do the georeference, if we go, it is automatically fixed it when you click the snapping, otherwise this kind of overshoot, undershoot it is happen. See, look at here, one line is there I want to connect it exactly here, but it goes somewhere here, this is called that overshoot. Okay. So, these all are the things we have to carry out to check the quality control measure when do the georeferencing. Here output integration, once we digitize polygon feature, line feature and area feature, that format, the file format is the .shp, which means the shape file. See, VLC have one format, then Word, .pdf, these all are that some format is there. Then our geometric shape file, the file system they follow that .shp. So, our layer, point, line and area layer saved, we give the name and file format is the .shp. Then our layer we have to cross check, we want to interpret or we want to check that with the satellite image and DEM data, you know the DEM data, digital elevation model, then other GIS data set we have to compare, we have to analyze, these all are the things is possible here. Then further we do the thematic mapping and other information also we can add it. Once we done the digitization, these all are the things we have to carry out further analysis. So, application of digitized topo sheet. So, first is the terrain analysis. We can you know that the topo sheet, the line represent that same elevation, we call that contour. So, contour is there, there is from the contour we can analysis what is the slope, what is the elevations, either it is a steep slope or valley, this kind of information we can get it after the digitization. Then disaster management, the data we can compare with that present data, we find out that where that possible high disaster, this thing we have to carry out, where the risk is high, this other thing we can get it here. Then land resources, land use, land cover, in 1970 our topo sheet, what is the land cover in that area, in presently cross check with that satellite images and aerial photo, and what is the difference between 1970 and 73 and presently what is the changes it happen, which land use, what is the conversion of that land use in presently. Then hydrology, water bodies is there, that water body what is changes presently, where is the we have to build the check dam and the river pattern, this kind of information we can follow through that hydrology things. And infrastructure, so where we build that road network and building smart city, these all are the things we carry out. Once digitize, then we can follow, we can analysis based on the digitized our data to present data, we can compare, everything is possible once we get it that our vector data through the process of digitization. So, what are the advantages is there for the topo sheet digitization? First is the data preservations. The topo sheet 1970, 71, 72 that time, that is a historical data. So, we can get it analog to converted into the digital, we can store that. So, preserve that historical data. So, already I mentioned that how to trend is going, what is the land use changes. So, this thing we can carry out from the data preservation. Then measurement precision, accurately we can possible to measure. So, what is the length of the road, what is that area of that water body, this thing we can carry out accurately we can possible to measure. Data integration, combination and with the other data, aerial images and satellite images, compare that and based on that we can make a good decision for the planner and sustainable developer. These are the things we can carry out. Then this is one of the main advantage of the topo sheet digitizations. Then limitation and challenges, when we do the digitization that file, what are that hinder we face? Quality issue. So, quality issue means that historical data may be some clearance issue and quality issue also is there, and time consumption. So, maybe is a one topo sheet, it is a cover a part of district or part of taluka, this thing, because the topo sheet surveyed and mapped it is 1970-72 that time. So, therefore, when we do the digitization, it take a time consumption. We want to give that more accurate vector data, means we want to slow digitization and accurate digitization. Therefore, more experienced person, the technical knowledge people is needed. Then accuracy also dependent, little bit vary between the present data and historical data. So, these all are the things, main challenges and the limitation of the topo sheet digitization. So, what are the GIS software presently we are using for the digitization? Mean ArcGIS, MapInfo, AutoCAD, Global Mapper, these are the commercial software we are using, but in the student for perspective, we are using the QGIS, that is a open source software, and CrossGIS and GVSig and Saga GIS, we are mainly advised to do the digitization for students. Then key takeaway, topo sheet digitization is that first we want to input that sources of the topo sheet is must be clear, and clearly we have to scan it and geo referenced, and layer creation, point, line and area, like that we have to create that layer, and valuable conversion, that is a paper topo sheet we converted into the digital format. Then we have to focus the quality, either that digitization line, polygon and point feature exactly fix into the ground or present satellite images and aerial images. This is the way we have to check that quality, and whatever we give the input accurately, then output we are expecting accurately. So, this thing is a takeaway from the point of view of digitization of our geo-referenced topo sheets. So, now we are going to do that practical session, how to we do the digitize. So, this is the QGIS software, we already done geo-referenced. Now, I inputted that software, go to the layer, my geo-referenced topo sheet is a raster format, then I add it. Now, I added this topo sheet here, this is the geo-referenced, exactly our topo sheet merged with our real world. So, this is the geo-referenced, we already done the process of geo-reference. So, when we do that digitization, we have to check that either this topo sheet is geo-referenced GCS or PCS. What is the sources of topo sheets? General character, they either is a GCS or PCS. So, now you have to check that, go to that here properties, here informations, in the information here you see that WGS 1984, this is the GCS, geographical coordinate system, check that here. So, geographical coordinate system means our topo sheet we can visualize on the globe, we can't measure anything, what is the length of road, once we do the digitize point and line and area. So, what is distance between one point to other point, and what is the area of the polygon, what is the length of the road, this is not we can measure when we our topo sheet under the GCS. So, therefore, we converted into the PCS, projected coordinate system. This geo-referenced topo sheet, this geo-referenced topo sheet is the GCS, geographical coordinate system. Once we converted to the projected coordinate system, then only we can measure what is that area, what is the distance, what is the length. So, we have to do that PCS conversion of our topo sheet. So, follow that. Here export save as, right click our topo sheet, geo-referenced topo sheet, go to the export and save as. Here you check it, our file format is a GeoTIFF, file name I navigated where I am going to save here money georeference data, here georeference underscore PCS, projected coordinate system, that is a geographical coordinate system. Now, I am converting GCS into PCS, projected coordinate system. You know the projection, projection means 3-dimensional earth we converted into the 2-dimensional plan surface, then only we can measure. Then save it, you go to that, here we check it, WGS 84, WGS 1984 and universal transfer Mercator projection zone 44 north I gave it. We already discussed why we give that 43, 44, 42, 45 for the India, that is we discussed already about the grid system. So, this topo sheet come under that WGS 1984 universal transfer Mercator projection zone 44 north, then I gave it OK, then I will give OK. So, there is a converted GCS into PCS topo sheet here in the layer. Here I do not need this GCS layer, therefore, I removed this. So, you cross check it, go to the properties, here information. So, look at here WGS 1984 UTM zone 44 north, that is a projected coordinate system, then I give OK. So, now we create the layer, then we do the digitizations. So, go to the layer, here create layer is there, create layer, new shapefile layer. I already told that what is the shapefile, that is the ESRI format, new shapefile. Here I give that I want to digitize point future, for example, settlement or benchmark or other temple, post office or religious center, it is come under the point future. So, file name is that I navigate where it is going to save. So, you navigate where that is folder in your folder, here I will give the point or settlement, then save, then UTF means the font style cannot changes, then geometry types is a either if you point future means you give the point, or road or river means you give the line, then polygon future forest and water body you give the polygon future. Here I want to digitize only the settlement, then geometrical type is the point future, then here you give that 44 north, then OK. Then we saw attribute data. So, attribute data also what is that name of that settlement or name of the villages, that you can give it. Here I will give the name underscore settlement. Yes, here is the that name come under the text or integer or decimal. So, name it come under the text, I will give it. So, what is the length of that or 80 numbers of text I am going to use, maybe I will reduce that 50 like that, that is your wish. Then here I added that, here is a name, similarly you can add that length of the road, area of that water body, like that you can add, based on that you give the integer value or decimal value, that is your wish. Then I will give OK. Finally, that layer it showed here, once you create the layer, that layer come under here. Then another layer also I am going to create, go to the layer, create layer, new shapefile layer. This time I want to digitize what are the water body is there or major water body is there in the topo sheet, that only I am going to digitize. I will give that water bodies. So, water bodies, that is a file format is the shape file, then save, that is a Unicodes, then geometric type is that water body, it is a any river stream is there means you give the line, or any lake or pond is there you will give that polygon. Here I am going to give polygon, then here this time I give the area. Area may be in that decimal, because exactly it is not integer, it is a 0.1, 0.2, 0.3 like that, it is increases. Therefore, I will going to give decimal, the length of the decimal or length of that the value is that maximum 20, then add field list, that is added. Finally, I give the OK. So, we created settlement, that is a point feature, then polygon feature is the water body, then we have to trace some line feature. So, again go to the layer, create layer, new shape file, already 2 is there, settlement and water body, 2 layer. Here my third layer I am going to digitize what are the line feature is there, or major line feature what is there in the topo sheet. Here road ESRI format, that is a shape file. The next is the geometrical types, we already gave point feature and polygon area feature. Now, I am going to give line feature, then here I am going to save that projectional coordinate system UTM Mercator projection 44 north, then OK. Here I want to find out the length of the road. Here length of the road is a maybe come under the decimal, you can possible to change as 10 or 12 or 20 like that, you can changes here. Finally, I give that add that field, usually ID name is automatically came, but is a length or other name of the settlement or name of the water body, likewise you have to create it, that is called that attribute data. See, the settlement is there, water body is there, road is there. So, settlement is a point feature, water body is the area feature, road is the line feature. We created shape file, also we called that we created layers, that layers is a .skp shape file format, this is the vector data. So, listen, this topo sheet is the raster data. So, we created vector data shape file. Now, we going to digitize first settlement. So, here stop editing is a very important. Look at here toggle editing. So, I create the toggle editing, which means start editing. When you do that start editing, once you digitize that, you trace the point feature, then finally you give the stop editing. So, you have to important note it this. So, once you give the start editing, this point feature is a enable, you can add it, that you take this wherever you want, you can add it, you will give the 1 or here is a 2. For example, I randomly put it, but when you do the analysis or further uses, you have to carefully pointed it. Here name also you can give it Rajaji state, Rajaji settlement, Rajaji village, like that you can give it your name also. So, I created point feature, then road feature, that is a line feature is enable. Here I digitize, when we do the digitize, you have to zoom it maximum, otherwise you look at here there is a error is there, my road is there, my digitization is somewhere. For the practical purpose, for the teaching purpose I am doing like that, but you people digitize very slowly and carefully, you put point very closely, that is very important. I put one point here and another point here, means that geometry may be destroyed. You see my road shape is going here, but I follow that maximum distance, means that geometry shape is the destroyed, that is why you have to point at it very closely. So, you reduce your error, then you right click, you will give the name ID number 1. So, here one road is there, you take the pan tool, if you move here and there, then again I take the line and zoom it. Row number 2, then OK. Row number 3, so that is enough. Then water bodies, take the polygon feature, so water body 1 and 2, 3, 4. Likewise, you can possible to digitize. So, you know that what is the line feature you are going to digitize and what are the point feature you are going to digitize, what are the area feature you are going to decide. You pre-plan and you have to consider about that how much time it is going to take, and these all are the thing you have to carry out when we do the digitization process. Then once you digitize that entire topo sheet or part of that topo sheet, you give that save layer edit. Save layer edit, when we do the start that editing, that time is the toggle editing, then save editing. So, based on the road, there is a line feature is enable, water body means you look at here, polygon feature, settlement means point feature. What are the geometry when we create the layer, that time we gave, that is enable here. This are the process we have to carry out, we do the georeference. You have to keep in mind, when we do the georeference, we have to put that very closest point, and you know that overshoot and undershoot. Therefore, you want to enable the snapping. So, once we digitize, we have to give that save edit. So, start editing and stop editing. So, these things we have to keep in our mind. Then this is our digitized point feature, line feature and area feature. Then go to that properties. For example, I go to the properties here, symbology, we can change the our road color, this thing, and water body we can give that some colors, and settlement also we can give that point like that, you will give it and name it, what are that water settlement name or villages name, what are the line road network name, and what are that water bodies is there, this everything we give the name. And once we digitize, this is that vector data, we stored that in the database, or whenever we need we take it, we preserve that data from the old topo sheet. Then we find out that length of the road, distance between one point to other point, that perimeter of that water body. So, everything we can calculate it, we can interpret it from the topo sheet, what is that length of the road. So, presently what is the length of the road, what is that water body is there in 1970, in that satellite images in presently what is that water body area, we can compare. So, these are the process possible. Once we digitize our topo sheet, then we compare with that satellite images and aerial photo. Further we analyze that urban plan and land use, land cover changes, these are the things. So, we completely now understood the digitization process, vector data creation, these things. Thank you.